Hey guys, welcome back. Welcome to Vedantu JEE channel. How are you all? I'm sure all of you guys are looking forward to this week और इस week में इंडिया का सबसे ज़्यादा celebrate किया जाने वाला and the most awaited festival is here. Yes guys, I know that all of you are super excited for the holidays that you might be getting. I know more or less for last 6-7 months we all are kind of on a vacation, but I'm sure स्कूल के क्लासेस से हमें ब्रेक मिलने वाला है और इस ब्रेक में हम लोग हमारे फैमिली के साथ में एक बहुत अच्छा टाइम स्पेंड करने के लिए वी आर लुकिंग फॉरवर्ड टू इट राइट गाइस। सो आई वेलकम यू ऑल बैक टू दिस स्पेशल सेशन जहां पे हम लोग बात करने वाले हैं अबाउट फेस्टिवल दिवाली, बट दिस टाइम इट्स गोइंग टू बी with a little twist. Yes, हम लोग बात करेंगे about things which we do in Diwali, and those are the one of the most exciting part of Diwali in general. That is about different fireworks that we all see, right? So we are going to see the physics behind it. And exciting and interesting. I'm sure that you all are looking forward to understand that how come physics also gets related to this festival of light. वैसे तो फेस्टिवल ऑफ लाइट में जो लाइट वाला फैक्टर है इट itself brings the feeling of physics in it, है ना दोस्तों? Good. So I'm going to tell you, I'm going to take you through, in fact, about different cases, different fireworks, crackers, and all those things with respect to physics behind all of them. Okay, guys, so let's start. And for those people who are new on the channel, who do not know me, who are on the channel new, let me start off with my introduction. So, guys, this is me, your Suri Sir, and I am a BTech from IIT Bombay. और इस चैनल पे मेरे स्टूडेंट्स मुझे मोगैम्बो बुलाते हैं. Why? Because when you will crack this examination of JEE, for that matter NEET also, मोगैम्बो खुश होगा. Okay, guys. Also, अगर आप चैनल पे नए हो और ऐसे एक्साइटिंग सेशंस along with academics, along with motivation, along with information अगर रेगुलरली रिसीव करना चाहते हो तो all you have to do is subscribe to the channel right now and press the bell icon so that you never miss out on any of these sessions which are happening on this channel. Okay guys, cool. So guys, let's talk about the physics behind Diwali, right? But before that, let me wish you all very happy Diwali in advance. And I'm sure this festival of light will bring a lot of prosperity, a lot of happiness, and definitely the success that you all are striving hard for. Right, guys? So fingers crossed. Let's keep on working. So, आज गेयर को थोड़ा सा चेंज करते हैं और बात करते हैं अबाउट द फिजिक्स बिहाइंड द फायरवर्क्स. राइट गाइस? तो जब हम फायरवर्क्स की बात करते हैं, इतने सारे डिफरेंट टाइप्स ऑफ क्रैकर्स होते हैं, पटाखे होते हैं जो हम लोग दिवाली के टाइम पे चलाते हैं. राइट गाइस, हो सकता है कि इस दिवाली पे हम लोग फायर क्रैकर्स कम चलाएं, बट द फिजिक्स बिहाइंड इट इज स्टिल गोइंग टू बी समथिंग व्हिच इज एंजॉयबल. राइट, लेट्स फील लिटिल नॉस्टैल्जिक बिफोर वी सेलिब्रेट दिवाली. एंड देन दिस टाइम जब आप लोग दिवाली के क्रैकर्स अगर चलाओगे तो उसके पीछे की फिजिक्स के बारे में सोचते हुए आई एम श्योर दैट यू गाइस वुड वांट टू शेयर इट विद योर फ्रेंड्स, विद योर फैमिली मेंबर्स, एंड इफ यू हैव यंगर सिबलिंग्स, this could be one of those you know those moments, those things which you can actually uh, tell your siblings, younger siblings, or younger kids around you, to tell them that how much you are learning physics and how interesting physics is in general. Okay, people. So, without wasting any further time, let's speak about the very first firecracker. और जो सबसे पहले और सबसे ज़्यादा पॉपुलर फायर क्रैकर हमारे दिमाग में आता है, take a guess. Yes, guys, that is nothing else but rocket. तो रॉकेट के पीछे जो फिजिक्स है, ऐसे तो बहुत सारी फिजिक्स साइमल्टेनियसली इन्वॉल्व होती है, बट आई वुड लाइक योर अटेंशन टू कम ऑन योर वेरी 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 पॉपुलर लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम. राइट पीपल, बहुत सारे क्वेश्चंस हम लोग सॉल्व करते हैं मैकेनिक्स में जहां पे हम लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम को अप्लाई करते हैं, बट व्हेन वी ट्राई टू कलेक्ट एंड ट्राई टू थिंक अबाउट इट with respect to real life example of rocket, the firecracker, let's think about the momentum of the firecracker. So guys, जब रॉकेट को हम लोग इग्नाइट करते हैं, रॉकेट इज वन ऑफ दोज क्रैकर which starts going up in the air, right, without anybody actually throwing it upward. When it starts to go up, what do you think is providing it the upward force? Can you think of it? Yes, guys, you are right. Rocket without ignition will not be able to take that launch. So once you ignite it, what happens? You have a gunpowder or the complex chemical compound which is there, which can easily catch the fire. तो एक बार जैसे ही हम उसको ignite करते हैं, the burning material, it starts the combustion, and the exhaust gases starts to come out, and that too in a direction that is downward. Obviously, whenever the exhaust gases will come out, they will require a force, and if that force on the exhaust gases is acting downward, you know that by the action reaction law, yes, one other law of physics which gets related here, uske according, the force in the opposite direction must act on the body of the rocket, and the rocket will start taking a launch and it will start going upward. Now in this process, during the time when the force is acting only between the rocket body and the exhaust gases, that is where no external force is acting, and that is why we can say that law of conservation of momentum is responsible for your rocket to go up and the exhaust gases to come down. Right, guys? Next time when you're going to fire this firecracker, do think about it and do try to observe it. Okay? We don't just stop there. You know, guys, rocket is specifically that firecracker. Just say sound is also associated, right? Usually, when we have any firecracker, Lakshmi bomb, or normal firecrackers, right, guys? Atom bomb. I don't know what are the different types of names that you guys might be using for different types of crackers. But all those crackers which are, you can say, land crackers, जितने भी crackers को आप अपने सामने चलाते हो and they burst in front of you, you get a shrill sound out of there, right? But then वो जो shrill sound आप सुनाई देते हो, उसकी shrillness का level जो है, it does not change when it is ignited and when it gives you the sound. But when you have a rocket being launched upward, it makes a whistling sound, and the intensity and the frequency of that whistling sound as it goes up, it keeps on decreasing. Think about the Doppler's effect. Do you remember the Doppler's effect? Yes, guys, Doppler's effect वो effect है जिसमें frequency of the sound which is observed by the observer is going to be different than the actual frequency which is produced by a source because of the relative motion between the observer and the source. तो यहाँ पे source है आपका rocket और observer हो आप खुद. तो जैसे ही rocket ऊपर जाने लगता है, that whistling sound keeps on getting fader and fader. The frequency of that, the shrillness of that keeps on decreasing because of the Doppler's effect. Okay? Cool. तो ये तो बात हो गई rocket के बारे में. How about the next very popular firecracker? Yes, guys, Chakra. और नॉर्थ पार्ट में अगर हम बात करें, नॉर्थ ऑफ द कंट्री, वी कॉल इट चक्री, राइट गाइस? तो कभी सोचा है हाउ एग्जैक्टली इट स्टार्ट्स टू टेक दैट स्पिन? व्हाट डू यू डू इन दैट पर्टिकुलर क्रैकर व्हिच यू गो फॉर? आप उसे सबसे पहले जमीन पे रख देते हो एंड यू विल इग्नाइट इट वंस अगेन. ऑल द फायर क्रैकर्स ऑब्वियसली दे विल रिक्वायर द इग्निशन. तो जैसे ही आप उसे इग्नाइट करते हो, obviously the complex chemical mixture which is there, including the gunpowder material, mixed with a lot of complex organic and inorganic compounds, when it starts to burn, it starts to again start releasing the exhaust gases in a complex manner, that spiral shape which is being given to this particular cracker. उसकी वजह से आपका ये फायर क्रैकर जो है, it starts to experience a tangential force, और उस tangential force की वजह से there is always a torque which is acting on it. And because the force which is acting is tangential force, you know that tangential force is the only force responsible to provide the torque. And as that force keeps on acting, the speed of this chakra keeps on increasing, right, guys? So that is where torque comes into existence in order to make it rotate. And we know that the fundamental reason behind the rotation of any object is basically torque. But people, you know that जब पूरा का पूरा गन पाउडर मटेरियल या जो कॉम्प्लेक्स केमिकल कंपाउंड विच इज बर्निंग ओवर देयर, व्हेन इट गेट्स बर्नट आउट, जब पूरा का पूरा जो गन पाउडर मटेरियल है वो बर्न आउट हो जाता है, उसके बाद भी चक्रा कीप्स ऑन रिवॉल्विंग, राइट, एटलीस्ट फॉर सम पीरियड ऑफ टाइम. At that point of time, there is no tangential force or a torque which is acting because of the burning material because it is completely exhausted, but it keeps on still spinning because of the momentum it carries. Which momentum? Angular momentum. But we know that after some time it stops. Why? Because there is an external force which is acting, which is providing a retarding torque, which is nothing but the friction which is provided by the ground on which you are ignited it, right? Think about this situation. After the fuel is completely burnt out, if this firecracker would had been on a very smooth surface, yes guys, your chakra, after the fuel combustion is completed, will continue to move with that angular momentum and will not stop because there will be no external torque acting on it. And yes, the law, the conservation of angular momentum, will make this possible for the chakra to continue to spin for a long duration of time and theoretically an infinite duration of time. Right, guys? So, next time when you go for a chakra, think about the torque and the law of conservation of angular momentum. Try to do this on a smoother surface and a rough surface. You will see the difference of rotation lasting for a longer time on a smooth surface. Yep. Speaking about a bomb now. Usually with the name, it comes with the name of atom bomb. Now why it is called atom bomb, उसके बारे में भी बात करूंगा, बट पहले बात करते हैं जनरली बर्स्टिंग क्रैकर्स के बारे में. अलग अलग तरह के क्रैकर्स होते हैं. छोटे क्रैकर्स भी होते हैं which will make relatively lesser sound. Then there are bigger bombs and उन सब में सबसे ज़्यादा नॉइजी साउंड प्रोड्यूस करने वाला, सबसे ज़्यादा एक्साइटिंग साउंड प्रोड्यूस करने वाला जो क्रैकर है, उसे क्रैकर बोलना भी एक्चुअली इट इज inferiority for it. You call it an atom bomb, right guys? So how exactly gas laws comes into picture when we are speaking about an atom bomb or a cracker in general? So basically, how thermodynamics plays a role here. When we speak about the body of any cracker or specifically any bomb, the combustible material is packed so closely inside the wrapping material that when you are going to ignite the cracker, the bomb, the temperature because of the combustion will rise to a very great amount. In fact, it goes close to 1000 degrees centigrade for that duration. Considering that for that small duration of time, the body of the cracker, the body of the bomb is going to act like a constant volume structure. In that constant volume, let's think of PV equal to nRT. If the value of temperature is going to increase, definitely the value of the pressure is going to be proportional to it. Yes or no, people? The pressure is going to be proportional to temperature, and because of that, as the temperature is increasing, the pressure will keep on building inside. The moment the pressure becomes so unbearable for the body of the cracker or the bomb, will burst out. Larger be the value of the pressure, larger is going to be the noise, the sound that it is going to produce. And that is why next time ये notice करना, जो छोटे क्रैकर्स होते हैं उनका जो रैपिंग मटेरियल होता है उसकी डेंसिटी बहुत कम होती है, और जो आपके एटम बॉम्ब या सूतली बॉम्ब या लक्ष्मी बॉम्ब जो होते हैं, आप अगर उनको नोटिस करोगे तो यू विल फाइंड दैट दे आर वेरी टाइटली वोन्ड. इनफैक्ट उनके ऊपर जो नंबर ऑफ लेयरिंग्स होती है वो भी उतनी ही ज्यादा होती है ऑफ द रैपिंग मटेरियल विच दे यूज. Why do they do that? So that the volume can be held tightly for a longer instant, for a longer duration, so that when temperature is rising, the pressure will also proportionally rise much more, and eventually when the pressure reaches that high value and it bursts out, it will produce a very strong sound, right? That is why the small crackers will make lesser noise and the big bombs will make much more sound in comparison to that. Okay. About sparkles, we all go for it, especially whenever we have to go and ignite any of those firecrackers. We usually go for the sparkles. They are usually the starters also, right guys? So how exactly this new concept or next concept, that is thermal capacity, gets associated with it? कभी ये नोटिस किया है कि जब आप उस फायर क्रैकर को, स्पार्कल को जब आप अपने हाथ पे रखते हो, फुलझड़ी जिसको बोलते हैं, when it is ignited, it gives away so much of sparks, and definitely the temperature is very high because it is burning at the moment of time. You very comfortably hold it towards the other end, and a lot of that sparking material touches your hand also. but I'm sure you must have noticed it, or if you never noticed it, you can now recollect कि कभी भी वो sparkles जो आपके हाथ पे गिरते हैं, they never give you a very strong burning sensation. How about that? Even when the temperature, as I mentioned, is close to 1000 or till 16,000, 1600 degrees centigrade, the temperature goes to that high level. You know that even when 100 degrees centigrade water, in fact 100 degrees is a very large value that I've spoken, even if a 50-60 degrees centigrade temperature of water falls on our skin, we feel quite irritation of the burning effect that we get. But when we are speaking about 1000 degree plus sparkles falling on our hand, we don't get that unbearable burning sensation. What is the funda behind it, guys? The funda of thermal capacity comes into picture here. What is thermal capacity? I hope you guys know and recollect that it is the product of mass and the specific heat. तो अगर हम बात करते हैं specific heat of the burning material की, that is something which is going to be a constant. But what plays a very important role here is basically the mass of the sparkling materials which are falling, sparkling drops which are falling on your skin. They are going to be very, very small in amount. And when the mass which is falling at that high temperature on your hands is very small, the burning sensation is also something which is so less that you can't even actually feel it to a very unbearable level. Okay, just to relate to it, let me give you a very relatable example, something which is related to Diwali but not related to firecrackers. तो दिवाली के टाइम पे हम बहुत सारी स्वीट्स खाते हैं, उसमें से एक स्वीट है वो डेफिनेटली आप सबको पसंद भी होगी, एंड द नेम ऑफ दैट स्वीट इज गुलाब जामुन, राइट? तो गुलाब जामुन एक ऐसी स्वीट है बच्चों जिसे हम सबसे ज्यादा एंजॉय करते हैं व्हेन इट इज हॉट, वेरी वार्म हॉट. तो मान लेते हैं घर पे अभी अभी गुलाब जामुन बने हैं, okay, and they are very hot. Okay, whenever you do the tasting of a gulab jamun, if you will pick one and directly put it in your mouth, if it is very hot, you will feel the burning sensation and you will be like, you will not be able to bear the heat that your mouth will get out of it. Right, guys? But if the same gulab jamun, if you take a scoop out of it, very small scoop out of it, and if you taste it, then the burning sensation is not unbearable. तो क्या टेम्परेचर डिफरेंट हो गया? डेफिनेटली नॉट. सेम गुलाब जामुन, सेम टेम्परेचर, when consumed in a larger amount, even when the specific heat is same for both the cases, the mass that you are consuming in that case is smaller when you are taking a small scoop, and that mass will result in lesser heat capacity when the mass value is less. Hence, the burning sensation will also be less. Similar goes with the case of those sparks which are very, very small amount falling on your hand, still making it bearable, and even when they are at very high temperature. Okay, so this is how the thermodynamics get related with your sparklers or fuljadi. And last but not the least are basically those amazing fireworks which we see on television, and nowadays we all must have seen it in different functions, not just in Diwali. So how exactly the phenomena of emission spectra gets related over here? A quick recap of emission spectra. You know that whenever at atomic level electrons make a jump from higher energy level to lower energy level, they always will release the energy in the form of electromagnetic radiations, which are going to be ranging from lowest to highest of the wavelength. Somewhere in between lies your visible range also, right? Palmer series of emission spectrum gives you the visible lights. So guys, the complex combustible material which we use for all the crackers, it specifically burns at a temperature, and at that temperature it gives a particular type of color. How exactly those fireworks which give you different colors come into existence is during the manufacturing. The the complex mixture that I'm talking about, the manufacturers will add different chemical compounds of different metals also. Different metal oxides are added along with the chemical burning composition of the gunpowder material. So when you are going to fire those fireworks, when they go up, different metals, when they are going to be at that high temperature, at atomic level, different metals, they will have their electrons at atomic level reaching to the higher energy level. And when the electrons will try to go back to their native states, they will release their energy depending upon the composition and atomic structure of different metals that we are speaking about. Different radiations will be emitted, and those which are lying in visible range will give you different colors of the Vibgyorels over there. Okay, guys. So that's where emission spectra makes this beautiful combination of different colors of fireworks possible. For example, guys, if I give you specifically what are the metals which are added or their chemical compounds which are added along with the combustible material, strontium, calcium, sodium, barium, and copper are five of those. When strontium goes to that temperature, the color which is emitted by compounds which are made up of strontium, they will give you the reddish color. Similarly, calcium at that temperature will give you orange color. Sodium, I'm sure most of you are aware about it. It will give you yellowish color. Barium, on the other hand, will give you greenish color, and copper will give you bluish color. So different metals and their chemical compounds, when mixed, because of the emission spectra of the visible range, you are going to get those different colors of fireworks. Okay, guys. So as I said, there is physics around us, and there is physics during Diwali also. So this time, when you are going to enjoy Diwali, if you happen to enjoy Diwali along with the crackers, don't just take the fun in just bursting them. Try to brag off the physics behind it that you now know to the people who are around with you, and definitely enjoy this Diwali. And obviously, I'm sure you are going to enjoy Diwali with your family members. Do stay connected with Vedantu. I wish you all very happy Diwali in advance. Wishing you again all the success that you guys are looking for, that you guys are striving for with respect to your preparation in JEE examination or NEET examination for that matter. Okay, to make it even more prosperous for all of you, if you are sitting at home still thinking of JEE preparation and still confused, how do I continue my JEE preparation even while being at home and still staying safe? So you don't have to go out to any of the physical classes in order to continue your JEE preparation. I know that there are a lot of risk factors involved. You can continue your JEE preparation at home with your very own Vedantu. And to make it even more special, we have special discounts for you guys to study and continue your JEE preparation at your home itself. What are those? We are giving you straight 50% discount on your subscription fees for the Vedantu subscription plans, guys. We have 50% off on any of the subscription plans. You can go for 1 month, 3 months, or 6 months. 2021 students, if you are looking and eyeing for January month, then you can have a 1 month subscription or a 3 month subscription. Or if you want to keep the April attempt also in mind, you can go for 6 month subscription. You can see that you are getting a huge discount on your subscription fees up to 10,000 rupees. And all you have to do is use the coupon code SMPRO to take this advantage. Not just 2021 students, for 2022 students, जो बच्चे अभी 11th standard में हैं. So guys, be it 1 month till 12 months, you can also avail your subscription fees discount of 10,000 rupees, a humongous discount at these subscription fees by using this coupon code. Okay, and also people who have taken a drop will have the subscription plan for you also. Okay, guys, not just that, if you are looking for a crash course, I'll tell you that as well. All you have to do is go on the link of the different subscription plans which are available in the description box and use this coupon code SMPRO and make sure that even at home your JEE preparations are continuing. For people who have taken a drop and are going for a crash course, interested in that, crash course is now available for just 8,000 rupees. A new batch has started this Monday only. Remember the coupon code SMCC and you can enroll for the same. Okay, guys. So I hope you guys will take the maximum benefit out of these offers so that you continue your JEE preparation and achieve your dreams without any hurdles. So people, this brings us towards the end of the session. One quick information: if you are still not on the Telegram group, and if you are still missing out on daily updates, assignments that we provide and their solutions and the study material, you can be a part of Vedantu's Telegram group, which is also free of cost, by the way. Link for that is also available in the description box. Okay, so do join us. I hope you guys enjoyed this session, the physics behind Diwali. If you did, then do press that like button below there. Share with your friends so that they also get to know how physics gets related here. And if you have not, then go ahead, subscribe to the channel and press this bell icon so that whenever I'm coming live, get the notification. Guys, happy Diwali once again. Take care. I'll see you very soon. Bye bye.